All right, guys, so more systems of linear equations. This comes in the form of a word problem. So same thing, two variables, two equations, two variables. You have a bunch of quarters and dimes in your pocket. Oh, good for you. Altogether, you have 24 coins. Okay, so these are only quarters and dimes, and together you have 24 of them. The total value of all of these coins is $4.05. How many quarters and how many dimes do you have? Okay, tricky. So we're going to try and create some equations here that answer these questions. We know that some amount of quarters, oops, where's the pen? We're going to say that Q is going to be equal to the number of quarters. And D is going to be equal to the number of dimes. Okay, and we're going to make some equations here. We know that all of the quarters and all of the dimes equal 24 coins. Okay, so the number of quarters and the number of dimes equal 24 coins. And we know that the number of quarters times the value of the quarters, so 0.25 cents, plus the number of dimes times the value of the dimes is going to equal $4.05. So we're going to try and do some elimination to try and figure out what these variables are. So we have these two equations, but they have different numbers in front of them. So that's a little bit of a buzzkill. We're going to have to adjust one of these equations. Also, so we want the number in front of the variables to be the same. So like if we're looking at the Q variable, we would like both of those numbers to be the same, but also we want the signs to be opposite. Right? We want one of them to be negative and one to be positive. That way, when we add them, something will cancel. So, this top one is already a 1, like 1Q. I can put that in. If we don't see a number, we always assume 1. And I know that 4 quarters makes a 1. 4 quarters makes $1. So I'm going to multiply the bottom equation by 4 to make the Q's the same number. Let's do, but I also want to adjust the sign. I want them to, the bottom one to have a negative sign so that when I add them, they cancel out. So I'm going to multiply not just by 4, but I'm going to multiply by -4. And that's going to flip the sign of everything in this second equation. So we're going to get sort of an adjusted equation. The first one's going to stay the same. So 1Q plus 1D equals 24. Now the bottom equation has changed slightly. -4 times 0.25 is going to give us -1Q. And -4 times 0.1D is going to give us -0.4D. And -4 times 405 is going to give us -16.2. So just slight adjustment to the second formula. And now that the numbers in front of Q, I mean, we can adjust to make the numbers the same in front of D also, but we sort of have to just pick one or the other. So we just chose Q. We made the numbers the same, so they both are a 1 now, and one of them is the opposite sign, right? So one of them's a negative, one's a positive. Okay, so if we go to add these two equations together, now the Q's are going to cancel out. 1 plus -1 is no more Q's, right? So like 0 Q's. And then 1 plus -4 is going to give us, or -0.4 is going to give us 0.6D. And 24 plus negative 16 gives us 7.8. So we've been able to eliminate one of those variables. We eliminated the q's to find now that just 0.6d is equal to 7.8. What we'll do is divide both sides by 0.6, and we find that d equals 13. So we don't know how many quarters yet, but we know that the number of dimes is 13 dimes. Great. Okay, so let's take this information and try and use it to solve for Q, the number of quarters. Now, I'm going to sort of combine two things here. I'm going to combine that first equation. So I'm going to take Q plus D is 24. Except we know now that D is 13. So instead of D, I'm going to put in 13. Keep everything else the same. And now try and solve for Q. So the 13 is going to come over the equal sign. Q equals 24 minus 13. And we find that Q is 11. So if we had to summarize this, we would say there are 11 quarters and 13 dimes. That's great. Now, if you want to check that in a different way, so I mean, these two numbers are going to work in both of those equations. So if you put in 11 and 13 in the second equation, like the 405 equation, it'll work out. If you put those numbers into the first equation, it'll work out. And this is just like the point of intersection of these two lines, right? And I know it's kind of weird to think about, you know, the number of coins in your pocket as having like a linear relationship, but it does. And just to show you, I'm going to take these same two equations and I'm going to put them into a graphing calculator. Okay, so that calculator is on the Desmos website, so desmos.com. And oh, I don't want to get rid of all that stuff there. And the tricky part with this website is it doesn't let you put in anything other than X and Y. So like our equations were Q and D, right? Right there, like Q and D. So I'm just going to change Q to X and D to Y. So instead of Q and D, I'm just going to put it in as X and Y. But let's see here what we get. X plus Y equals 24. And then 0.25x plus 0.1y equals 4.05. And you can see it's graphed a couple of lines for us, and those lines do intersect. Whoops. And oh, can we zoom in here? And our point of intersection is 11 and 13. Yeah, cool, right? So 11 quarters, 13 dimes. Anyway, so that's just how we solve systems of linear equations with the coin questions. Cheers, everybody.